Good morning, this is your Stat Sensei, Mr. Spensei, and this is Unit 2 Death Packet on displaying and describing data, and this will be problem 71 to 80. To which of the box plots does this histogram above belong? Well, first off, we can easily see that this is skewed to the right, and this one does not appear to be skewed to the right. That's skewed to the left. This doesn't look very good, but we'll hold on to it. Obviously, I don't like this one either. But let's figure out specifically how to do this. Well, I divided this up into boxes, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 boxes. Well, that means my median, if I have 16 boxes, my median is going to be 16 plus 1 over 2, sample size, and that tells me that it's going to be 8.5. Well, 1, 2, 3, 4, 5, 6, 7, 8. So 8.5 is going to be right here at the line of 10. Well, that means I need a median of 10. Well, that gets rid of B and D. And so now we're down to these two. All right. Now, just the fact that it's skewed to the right looks like it should be D, but let's look into this a little further. We need to identify where Q3 would be. Well, Q3 is going to be halfway between, remember we have 16, so we're going to want 3/4 of the way. Well, what's 3/4 of the way? Well, that means I need to, or I need to go another fourth. And if we have 16 boxes, I need to add 4 to this, would be at 12.5. 1, 2, 3, 4. So all of a sudden, 4.5 is somewhere between 20 and 30. So the one with it between 20 and 30 is right here. And the reason I said that is, remember, it's quartiles, and 16 divided by 4 is 4. So every quartile should have 4. So 1, 2, 3, 4. That would be somewhere between 0 and 10. We don't know where, but they put it halfway here. We have another 4, and that takes us here. This is 4, this is 4, this is 4, and this is 4. To add up to the 16 boxes. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12th box is somewhere between 20 and 30. We don't know exactly where. They put it right in the middle. Okay, so our best answer choice for this one is D. All right, moving on to number 72. Given that the median, and this should say median, should have an N on the end, is 270 and the interquartile range is 20, which of the following statements is true? 50% of the data are greater than or equal to 270. Guess what? That's the median is 270. That's always the case. The median will 50% will be greater than 270 and 50% will be less than 270. This is true every single time when we're talking about the median, and it doesn't matter the shape of the distribution. Number 73, a random sample of golf scores gives the following summary statistics. What can be said about the number of outliers? Well, the way we figure outliers is Q1, X has to be less than Q1 minus 1.5 times the IQR. And we need to figure out what our IQR is. So our IQR in this case is Q3 minus Q1, because that's our formula. And so Q3 is 91 minus 78. So our IQR is 13. So if it's less than this, so in this case, we have 78 minus 1.5 times 13. So let's do that real quickly. 78 minus 1.5 times 13. So I need a value less than 58.5. So if X is less than 58.5, it is an outlier. Well, my minimum value is 68, so I don't have an outlier on the low side. So none on the low side. But we should check the upper side. So Q3 If X is greater than Q3 plus 1.5 IQR, and Q3 happens to be 70 is 91, 91 plus 1.5 times 13. Let's figure out what that is. 91 plus 1.5 times 13 is 110.5. So is X greater than 110.5? And we look and we see that our max is above 112. Our max is 112. So we know the 112 is an outlier. Is it possible that we have a 111? Yeah, it is. It's actually possible we have more 112s. So we know we have at least one. We might have more than one. We don't know. We know we don't have any values greater than 112, but we could have 5 112s, or we could have 3 111s. So there might just be one, or there might be more than one, but there's at least one on the high side, but we have none on the low side. So the amount of omega-3 fish oils in capsules labeled 1,000 milligrams is measured for 4 manufactured products, yielding the following. It says, which of the manufacturer sample has the smallest range? Well, range is the largest value minus the smallest value. So which one has the smallest overall spread? And outliers are included in the calculation of range. So I can look at this and go, oh, that's pretty wide. That's pretty wide. This one is actually smaller than the others because it didn't have the outliers. All right, because this one has the 2 outliers, so that gets rid of that as well. So our best choice is C. All right, because remember, range includes using outliers, and that's why we don't like using the range if we have outliers, because it's greatly impacted by outliers because they're included in the calculation. All right. What will be the effect, if any, of removing both outliers on the graph below on the mean and the median? Well, the median should not be impacted. All right, the median should not be impacted. So, so the median will be unchanged. So we can get rid of. So we know it has to be one of these. The median will be unchanged. Could be B and C. Now look at this. 1, 2, 3, 4, 5. That outlier is 5 away from the median. And this outlier is 1, 2, 3, 4. 1, 2, 3, 4, 5 away. I'm sorry, I miscounted on that. 1, 2, 3, 4 away. So, wait a second. This is 5 away, and this is 4 away. So this means this is a lot higher, which is pulling my average up. This one is pulling my average up by 5, and this one's pulling my average down by 4. So what's going to happen is if I let go of this one, my average is going to go down a little bit. So the median will be unchanged, but the mean will decrease, because if this was 100, well, let's do that as scores. If this is a 50, 60, 70, 80, 90, 100, this is a 40, 30, a 20, and a 10. This is 40 points away, and this is 50 points away. That additional 50 points is pulling it up. So if I let go of it, it's going to go down just a little bit. All right. So my median will remain unchanged because the median is not impacted by outliers, but the mean will decrease. Number 76. Which of the following statements is incorrect? Both dot plots and sim plots can show symmetry, gaps, and clusters. This is incorrect. This is a true statement. We like that. Sets of data with different distribution shapes can have identical box plots. Believe it or not, that's true. Especially true if it's something like a mound shape, and then versus a something like this, or like this, a uniform. All of those are symmetric. If they're symmetric, they're going to have the same box plot, even though they are different. Box plot, dot plot, stem plots, and histograms can both show skewness. Pretty much true. In histograms, relative areas correspond to relative frequencies. That's also a true statement. In histograms, frequencies can be determined from relative heights. No. Not from relative heights. We have to actually know the numbers in order to find the frequency. To find the frequency, you have to have the number, not you can't determine it based on a relative height. Relative means we're dealing with percentages. So we can't determine frequencies based on the percentages. So tricky question, that's E. Given the histogram above and using the most commonly accepted definition of outliers, what values would be considered outliers? Well, that means I need to identify uh, Q3 and Q1 because I need my IQR. So IQR equals Q3 minus Q1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 boxes. So 1, 2, 3, 4 looks like Q1 occurs at 70. All right, 1, 2, 3, 4. It looks like Q3 occurs at 90. So my IQR equals 20. And to be an outlier, X has to be less than Q1 minus 1.5 times the IQR. So in this case, 70 minus 1.5 times 20. Well, 70, 1.5, let's do that on the calculator. 70 minus 1.5 times 20. We'd have to have a value of 40 or less. X would have to be less than 40. There's nothing here less than 40, so no outlier there. Checking on the high side, X would have to be greater than Q3 plus 1.5 IQR, which in this case, we said 90 was Q3. So 90 plus 1.5 times the 20. 90 plus 1.5 times 20 is 120. So if I had a value greater than 120, it'd be an outlier. But in this case, there's nothing like that. So in this case, there are no outliers. Number 78. Given the parallel box plots above, which of the following is true? All three distributions have the same range. Well, lowest and highest are the same on all of them, and that is a true statement. So wouldn't you know, letter A, all three distributions have the same range. So number 79. A data set includes two outliers, one at each end. If both of these outliers are removed, which of the following is a possible result? Doesn't mean it'll happen. Both the mean and standard deviation remain unchanged. False. Outliers will greatly impact the standard deviation. It's possible that they're equal distance from the center, in which case the mean might not change, but the standard deviation, the amount of spread will definitely change. So that's false. Both the median and standard deviation remain unchanged. Once again, standard deviation's definitely going to change. The median might not. Both the standard deviation and variance remain unchanged. Variance and standard deviation is definitely changing. Both the mean and median remain unchanged. That's possible. If the outliers are equidistant from the center, that could happen. All right. Both the mean and standard deviation increase. No, the standard deviation is going to decrease. We know it's going to decrease because the spread will decrease. So the only thing that's possible is D, not guaranteed for it to happen. The the outlier on the low side would have to be equidistant from the outlier on the high side. When there are multiple gaps in clusters, which of the following is the best choice to give an overall picture of the distribution? So we have gaps and outliers. We don't like mean and standard deviation for that. We like median and interquartile range. All right. We like the median and the median and the interquartile range. Box plot with its 5-number summary, stem plot, or histogram. I really prefer. Okay, so this is an okay answer, but we always have to look to see if there's a better answer. Box plot with its 5-number summary, useful, but we can't with clusters. We can't see clusters and gaps. All right, we can't see clusters and gaps, so that's not very good. Stem plot or histogram. Oh, that picture. These show gaps. They show clusters. They show outliers. We really like this. That's my best choice. So in this case, B is not a bad choice, but D is the best choice. All right, so letter D for number 80. All right, this is the end of this video and hope to see you on the next one. Thank you for watching.